Yeah, I beg somebody record. Someone's asking me if we are still here. Of course, we are still here. We have nowhere else to go. I beg. We are still on this. Okay, let's go. Okay, so stacks. So, but what consider our stacks? Do you remember from the learning? Anybody? Stacks. Stacks. Anybody?
Stacks are last in, first out data structures, but they are
Okay.
also like abstract data types. So
You also what?
abstract data types, like they are
Abstract.
not
ADT. Actually, it's
abstract.
ADT. ADT. Abstract
Yeah.
data type. Good stuff, right? So that's all you need to know, right? Like stacks, there's not really something that is called like a stack, right? It's actually kind of an abstraction. It's actually something we want. Then we have imposed it upon something. This is what I mean. So you have a data structure called a list, right? You're like, oh, you are a list. You do everything I want. You do everything. You're like, but now I don't want everything you have, right? You're like, hey, list, you do everything. We can insert in you, we can remove in you, we can reverse you, we can, what else can you do to a list? We can index you, oh, anybody, what else can you do to a list? Anybody? Oh, is that all you can do to a list? Like you can reverse it, you can index, you can remove, you can search, you can flip, you can add at end, you can add at back, you can add at middle. What else can you do to a list? Somebody has to say something before you move on.
You can
What
slide.
you can slice, yeah. What else can you do? You can just say everything. Huh? Nobody tells you you're not going to bed. What else can you do to a list? Hey, and today we can loop. ML has saved all of you, right? You can do basically everything to a list, right? But you're like, I don't want that thing, right? I just want some very restricted properties, right? And that is how come we create these ADTs, right? But you can take something that is very generic, that is very general. But you're like, I don't want these other features. I just want a subset of the things you can do, right? And using that subset, I create my own data type or my own data structure. Does that make sense to how to does what I just make sense? Does it make sense to everyone? Like if you're just imposing some restrictions to some existing data type or data structure, then it becomes yours. It becomes a custom one. That is basically how a stack is formed. Does that make sense to everyone?
Yes.
Okay, so now let's say there's restrictions we place on a list for you to form a stack. Also, I'm using a list for a reason, right? You can actually use a linked list or anything, but you're just going to be in Python. You're just going to use a list, right? So these are some of the restrictions you want. You're like, okay, for my stack, for you to be called a stack, please, all these things must hold. Number one, we can only actually, all these things is can only. So let's make the can only the mother. Can only add at end. What else? Anybody? What else? What else can you do? What other restriction? I've given you one. Can only add at end. Anybody?
Popeye.
Can only
Like
remove. Can only remove at end also. What else? What else?
I think read from the end.
Exactly. Can only read or access, right? Or only pick, right? At end, right? So that's basically what it is. And all these things have to be done in constant time. O of one, O of one, O of one, O of one, which means that if any of these things is violated, it is no longer a stack, no longer a stack. So you see people doing stacks, and at some point they're looping through it. No, it is not a stack. The moment you don't do these things, like you violate any of these things, or do something extra, it is not a stack. A stack only supports these properties. It only allows you to add at the end, remove at the end, and read at the end. Does that make sense to everyone? This is what a stack is. Please, does this make sense? You don't reverse, right? You're not going, I'm going to reverse. No, you're not making it a stack. It's not a stack. Does this make sense to everyone?
Yes.
Yeah.
Yes.
It's crucial. Like I think some people don't understand what we mean by these restrictions and the abstraction here. Like it's like that is what the data structure is designed for. Look, when you call, I think this is a mistake people come across, right? They create a variable, they call it stack. Then they initialize a list. And then they're like, oh, let me add something. They'll be like, let me reverse it. That's what I've called it a stack. Does not make it a stack. Oh. What makes it a stack is the operations you perform on it. If you call the variable a stack, and then you are making it do 360 degrees backflip and everything. No, it is not a stack, right? So the variable name is not what makes it the data structure. No, there's operations you're using it to perform. I can call my thing a queue. Sorry, I can call my thing a tree. Sorry, the thing, they have frozen our thingy. I should have signed in with the sorry, let me buy a subscription right now. Okay. I think I should have signed in with the I'm so sorry for this. Um mm, my other app, I bought one. I have to sign in. Can I even sign in quickly? Sorry, let's just use this. We don't have time. Okay. Okay. So what I said, sorry, I know what I said. So I'm like, you can only add at end. Yeah, we have to buy any subscription. You can only remove at end. You can only access or pick at end, right? Right. And I'm saying that the fact that you call something a stack like this and made it a list, and you can, and then you do like reverse this, like please, like it doesn't, right? It doesn't make it a stack, like no, right? Like it's a stack because of these properties. Does that make sense? I can call something a tree and call the variable tree, and this, and if I only do these three operations, it's behaving as a stack. So the data structure is defined by its behavior, right? By what you make it do, and not because you just called it a variable name or anything. Please, does that make sense to everyone? Is that clear? This is so important. Trust me, like it's so important. So important. Okay, can we go to the next thing then? Can we go to the next thing? Can we? So as usual, we have to start from the initializer, how to create and everything. So to create a stack, in Python, you can just call it a stack. You can just use a list under the hood, right? But again, a list can do so much more as we discussed. A list can do a lot of things, but we don't care about the lots of things it can do. We only care about these three properties. Understood? So let's do the first one. Add at end. How do we add to the end? How do we add to the end of a list? Anybody? How do we add to the end?
Append to the list.
So we do stack dot append, right? So add an item to the end of the stack is just dot append, then the value, right? Okay, how do you remove from the end? We looked at this last week. Anybody? How do you remove from the end?
Please, you pop stack dot pop.
Fantastic. Edward, I need to get you a check, 2-day-old check. Okay, each, what am I writing? I beg, give me a second. Stack dot pop, right? Stack dot pop. Okay. Somebody next. How do we access at the end? It's not stack dot access. You know, to cool thing about Python, my index -1, right? Right. So these are the operations, right? And sorry, okay. Okay. So these are basically what's happening. I've not used this thing in so long. Okay, good. So this is basically what we have for our stack, and these are the stack operations. So if you have a data structure and these are all the operations you perform on it, then indeed you're good. Yeah, using it as a stack. If you go and do what is there? Reverse, if you're going to do stack.pop index 0, removing from the front, it is no longer a stack. Understood? Because why? Because what's the time complexity of the append? Anybody? We discussed this, like I'm going for because we talked about all these things last week. What is the time complexity? If you didn't, please watch our arrays and lists and 2D list recording on YouTube. What's the time complexity of that append?
Constant
time, right?
Oh,
what about pop from the end? Constant 2, right? Please, any people to speak faster so we can finish it. What about indexing at the end?
Constant.
Yeah, we said indexing is constant time, right? Constant time. So that is how a stack is. So this basically, those of you are doing Python, but solving the question, anything, I have to use a stack here. This is all you need to do. Initialize it like this and only do these operations on it. Please don't go and do stack index. Let's say the middle value, like index 2. You are not doing a stack. You're just doing a regular list. Even though you call it a stack, it's a regular list. To confirm, now let's go. Now we may be asked to actually design your own stack, right? The question ask you, design, as we saw, we saw a design hash set. We've done that one. You can also be asked to design your own stack, right? Or a main stack or whatever kind of stack. I'm not going to do a main stack here. We did it yesterday. I think yesterday in the coding room, we designed main stack, right? Those who were there. So go and look at that question, main stack. I showed my approach. If you were not there, you can look at the huddle. We pasted some of the code there. So to design your stack is class stack, right? Your init, def, init. So the thing about designing data structures is this. Under the hood, you can write any code you want there. So you can just call it self.s and still use a list here. Nobody cares about that. Then we said you can add to the stack. We're going to call it push. We call it push to the stack. So when you're pushing, you have a value, right? The value is what you're pushing into it. Just be like self.append, self.s.append, right? This basically, if you have to design your own stack. self.append. Please, if you're in a coding question, like I'm going to use a stack, don't go and design your own stack. I beg. Time will beat you. Just use your Python. Like, you realize that even the code I'm writing here, just Python gives you everything. Just do it and go. Don't go and be like, so interview, I have to use a stack here. So let me design my class stack. You will not finish today. I beg. Don't do that there. Just do things. I'm just showing you can design your own stack, right? Okay, self.append, then the value, right? Then you can also do pop. Pop is how you remove it. So pop takes no argument, right? So then you just do, you first have to check if it's, actually you don't have to check, you have to first check if the stack is empty. I told you last week that whenever you are, actually it was today, right? That whenever you are popping something from, removing something from a data structure, first check if it is empty or not, right? So you first have to check if it's empty or not. So first check, but let's assume you have checked, because if it's empty, if you're trying to do return self dot pop, this can also be called remove. If you do self.pop and it's empty, this will throw you an error, right? Because you're popping from an empty list and that will give you an error, right? But if it's not there, then we also have the last function we call pick. Pick simply means, pick is different. Pick is like, tell me the element at the end, don't remove it. Pop or remove will remove the elements, right? Remove will remove the element at the end. But pop will just show you, right? So that'll be like value is equal to self.stack index -1. Then after that, it will just be like return value. So you see here, I didn't remove it, right? I just picked as it and I just gave it to you. Now, because you can see that the definition of a stack, we only have these 3 methods we implemented. That is why that is the only 3 things you can do. Like, look, if you design your own custom stack, these are the only 3 things you can, these are the only 3 operations. Let me flip it to blue. If you design your own custom stack, you can only push, you can only remove, you can only pick. That is why those are the only supported things you can do. Does that make sense to everyone? That is why you can't see reverse, you can't see index K or any of those things. Does that make sense to everyone? That is what a stack is. Comprenez-vous? Everyone understands?
Yes, sir.
Yes.
Okay, good stuff. Almost there. Trust me, almost there. Now let's go to a queue. Okay, before we jump to a queue. So everything's constant time. Fast. I love stacks. Stacks are amazing. My first interview was a hassle. The question was valid parentheses. I didn't even know what a stack was. I tried to use a while loop. God save me that day. And people look at me, it's like, what are data structures saying? I was like, no, please, I don't even know what it's like. So when I went on vacation that summer, I was like, nah, I need to kill this data structures thing. I was like, this easy thing. God have mercy. Okay, when do I use stack? Well, I like to use stack if I'm looking at something, right? If I'm looking at something, let's say 1, 2, 3. Then I'll come up. Please follow me carefully. It's just my own thing. So I'm trying to complete it as best as I can. I'm looking at something, right? Then I'm processing it. I'm like, let's say there are all these items here, right? All these items here. So I'm looking at them. Then I'm like, okay, I've looked at you. But then some guy in the future, based on some guy in the future, I'm going to have to make some decision on these guys I've already looked at. Then I use a stack. So what do I mean? Has everybody here solved valid parentheses? Please, you should have. This is a question for the week. Like, you should have. Okay.
Yes.
You're looking at something like this. Then you're like, okay, I'm going to process every of these elements, right? Like, you're like, I'm going to look at every one of these elements. But then whether or not I keep this guy, right, is dependent on some value I see in the future, right? Depending on when I see its corresponding value here. So I'm like, okay, you don't worry, I'm going to keep you. Okay, don't worry, I'm going to keep you. But like, why are you keeping me? I don't know. The future will determine it. So I'm going to keep you. I'm going to keep you. So I see this guy, I'm like, I've seen this guy, therefore I'm going to have to remove you, right? So that's my intuition for stack. Like, hey, I'm going to keep some things now, but the future will determine it, whether I keep you or not. And that future is in some predefined order. That's when I use stack. Like, hey, I'm going to keep you. The same thing as, like, for instance, if you use the browser history, right? Like when you visit a web browser, you visit your homepage, it gets pushed on top of a stack, right? You go to, you hit, let's say, you click a new link on top of a stack. You click another new link on top of a stack, another new on top of a stack. But if you hit the back button, back, it will pop the item off the stack, it will jump it off. Hit back again to jump it off. Hit back again, jump off. Then it comes. So web browsers use stacks. Not just web browsers, the backspace key on your keyboard, right? If you're typing like Cornelius, right? No, I will buy BMW competition, maybe the M5. Okay, M5 for Cornelius, right? Like now, right? You hit backspace, it will delete the W. Another backspace, N. That is full stop, not hit the rest. You buy it. It doesn't have to be now, but like, so you can delete the now. Deleting it uses the backspace key, right? And that is what a stack does. So as you are typing in MS Word or something, it's pushing the characters on the stack, right? So when you hit the backspace, just pop off, backspace, pop off, pop off, pop off, and you are there. But end that statement here. Okay, good. Can we go on to the next thing? That's what a stack does. Good, good. Are we good? Are we good to go?
Yeah.
Okay. Record that, please. Stop and restart the recording. We're going to do the cues and next now. See, we're going fast. Got just I gave you the materials to learn and everything.